Hello everybody, these are the video notes for lesson 6.1 and you can title this Right Triangles. Let's draw out two triangles. The first triangle, I want you to draw a vertical line just like that, and then a horizontal line just like this. The exact lengths don't matter too much, and then let's connect those two lines to make our triangle. The second triangle I want you to draw is draw a line, and then let's make it kind of like this shape right here. This triangle on the left, these two sides, they form a right angle. And a right angle is when two sides come together and they're perpendicular lines. So we have a 90-degree right angle here. And because this triangle contains a 90-degree right angle, we would call this whole figure a right triangle. Now on the left, none of these lines or sides intersect at a perpendicular way like this. So this triangle has no right angles, so we can say this is not a right triangle. It has no right angles. Now, it's important to distinguish between these two types of triangles because when you have a right triangle, there are specific properties that are true. Let's draw another right triangle here. Again, your exact lengths don't matter, but make sure that you have this right angle here. If you have a right triangle, you're going to have two legs. The legs are the two sides that are next to the right angle. I'm going to call this leg length A and this one length B. And then this longest side of the right triangle, let's label that C. And this side right here, we call this the hypotenuse. It's this long side right here. And what has to be true if this is a right triangle is that the length, whatever this length is of side A, that length squared plus whatever this length is of this leg squared is going to be, and we add those two together, it's going to be equal to whatever the length of the longest side, whatever the length of the hypotenuse is, squared. And this theorem is called the Pythagorean theorem. Pythagorean theorem. And I'm also going to make a note that this only applies to right triangles. So I'm going to say right triangles only. Right, you can't use this Pythagorean theorem with something like this because it's not a right triangle. Gotta have that right angle. Let me show you two examples of how to use this Pythagorean theorem. Example number 1. Go ahead and draw out a right triangle. This time, let's put the right angle on the right side. Like this. This length is going to be 4, this length is going to be 6, and you're trying to figure out the length of the hypotenuse, the longest side. We know from Pythagorean theorem that if it's a right triangle, I can take the length of one of the legs squared. So let's take 6, for example. That's one of the legs, so I can say 6 squared plus the other leg, which is 4, that squared, has to be equal to whatever this hypotenuse is squared. So for now, I'm just going to use the variable c to represent this long side. Okay, and I'm trying to figure out what is the value of c. What's this long length here? So we can do the math. 6 squared is 6 times 6, so that's going to be 36, plus 4 squared is 4 times 4, that's going to be 16, equals c squared. We're still trying to figure out what that is. Okay, 36 plus 16, we can add those together. We would get 52 is equal to c squared. I want to get c all by itself, and right now it's being squared. So to undo the squaring of c, I'm going to take the square root of both of these sides. Okay, now c squared, square root of that, is going to undo the squaring, so I'm just left with c, that's what I wanted to do, is equal to 52 squared. Now 52 is not a perfect square, so it's hard to do that in your head. You can use a calculator for this. And I want to show you, if you have a calculator, use it. If you don't have one handy and you have your phone, you can use your phone. If you have an iPhone, one trick is you can actually rotate the phone to open up and find the square root button. The square root button that you need is going to be right there. So I'm going to do 52 square root of that, 7.21, etc. And we're just going to round this to the nearest hundredths place, so 7.21. So the square root of 52 is 7.21. And so now I know that the length of this missing side is 7.21. Let's do one more example. In this example, draw the right triangle going this way. Here's the right angle. You're going to have the length of one of the legs. The length of the hypotenuse is going to be 13 squared, and then we're trying to figure out the length of this missing leg. It's a right triangle, so we can use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So one of the legs is 2 squared. 2 squared, and then plus we have this missing leg length here. So you can choose any variable you want. I'm going to choose the variable a. So for that missing side is going to be equal to the hypotenuse squared. The hypotenuse is square root of 13. So square root of 13 squared. Okay. 2 squared is 2 times 2, so that's 4 plus a squared is equal to 13 squared. Square root of 13 squared is just going to be 13. Because the squaring undoes the square root. I want to get a all by itself. Right now a is being squared and then added with 4. Undo the last step. So I'm going to subtract 4 from this side. If I subtract 4 from here, gotta keep it balanced. I'm going to subtract 4 from the right. On the left, The 4's cancel out, so I'm just left with a squared is equal to 13 minus 4 is 9. I want to get a all by itself, but right now it's being squared. So to undo this squaring, I'm going to take the square root of both sides. A squared, square root of that, I'm just left with a is equal to square root of 9. What number squared equals 9? What number times itself equals 9? 3. So the missing side length here of this leg is 3.